Hello my dear students. In the previous video we studied how to simplify the expressions having irrational numbers, and also we studied how to rationalize the denominators having irrational number. And now today we will learn some laws of exponents on real numbers, and also after finishing the exercise I'll give you some extra questions also related to the chapter, and those questions are very important, so please listen to the video, watch the video carefully. Laws of exponents are: when we are having two numbers having the same base but different exponents, different powers, but they are in multiplication, so we'll see that we can directly solve them by this law, that is a raised to the power m plus n. So here the exponents are getting added. When the numbers of this with the same base are in division, their powers can be subtracted and they can be simplified in this form. And here it should be there that m should be greater than n. Third law is a raised to the power m whole power n. You can just multiply the powers and then you can simplify the number. In fourth one we have a raised to the power m dot b raised to the power m. So there we can take the power as a whole of the product of both the numbers. These are the simple laws. Again we have also studied that a raised to the power 0 is equals to 1, and one very important point I am going to tell you here, that how come a raised to the power n is equals to a raised to the power minus n. How we are going to prove this? Now you can see that this is actually a raised to the power 0 and a raised to the power n, and this will give us by this law 0 minus n. So this is how we are getting that how a number which is in denominator, how the power of the number becomes negative when we are reciprocating it. And in class 8, if you remember, we came across a situation where we were finding the value of x, like x square is equals to 16. So x is equals to square root of 16. So x is equals to 4. So this square root actually can be written as 16 raised to the power 1 by 2. So in general, how do we write it? See, if I am having, if b square is equals to a, so I can write b is equals to square root of a, or we can write this as a raised to the power 1 by 2. So in general, so if we'll take this power of b as any number n, so we can write that if b raised to the power n is equals to a, b can be written as nth root of a, or b is equals to a raised to the power 1 upon n. This we are going to use in many places. Wherever we will feel difficulty in solving this root, we can write this as the power of 1 upon the root. Example, if I am having cubic root of 2, I can write this as 2 raised to the power 1 by 3. If I am having 4 raised to the power 3 by 2, this we can simplify in two ways. See how? First I can take 4 cube whole power 1 by 2, because just now we saw in one of the rule that a raised to the power n, m whole raised to the power n gives you a raised to the power mn. So by that rule only we can write 4 raised to the power 3 by 2 as 3 whole power 1 by 2. Now what is this? This is actually 4 cube, that is 64, and this is actually square root. So you can write this as 8, or you could have solved it here only as 64 1 by 2, and this is 8 raised to the power 2, means 8 square 1 by 2, so answer is 8. Or we could have solved this in this form, that 4 raised to the power 1 by 2 and whole power cube by the same law only, and here you can solve this as 2 square into 1 by 2, 4 can be written as 2 square, whole power 3, this is getting cancelled, 2 cube is equals to 8. So we are getting the same answer. And now we can generalize this fact as, if I am having a raised to the power m upon n, we can write this as nth root of a whole raised to the power m, or we can write this as fine, where m and n are integers and these are co-prime also. It means they don't have any other factor common other than 1, and also n is greater than 0. Directly move on to the exercise 1.6. Question number 1 we have taken. First part, 64 raised to the power 1 by 2. Now in these questions, first you should check the exponent and what is the denominator of the exponent. In that manner only you have to express this base of the number. That is, I can write this 8 square. I have taken 8 purposely because here the denominator of the exponent is 2. So this is why I have taken 8 raised to the power 2, so that I can cancel the exponents of both the numbers, and answer is 8. These are very easy. Actually we have done these kind of questions in class 8 also. So you will not find any difficulty in these questions. Now second part, here we can write 32 as the power of 2 and whole power is of 1 by 5. So we can cancel it and the answer is 2. Question number 2, again the similar kind of questions only are there. So how can we write 9 raised to the power 3 by 2? We can write 9 as 3 square and whole power 3 by 2. So you can cancel this. 3 cube we are getting, that is 27. Now the third part, see 16 raised to the power 3 by 16 you can write as 2 raised to the power 4 into 3 by 4, that is 2 cube, and it is giving us 8. Question number 3, you have to simplify this. So we can see this, there the base is same and the powers we can add because they are in product. So we will get 2 raised to the power 2 upon 3 plus 1 upon 5. So it will give us 10 plus 3, that is 2 raised to the power 13 upon 15. We just have to simplify, we don't need to evaluate this, so we can leave the answer here. And one more important thing, that whichever law you are using here, you will mention it on the right side, that this is a raised to the power m into a raised to the power n is equals to a raised to the power m plus n. In the same way you will be writing the laws in the previous questions also. Fine part, here we will use the law a raised to the power m whole raised to the power n, which gives us mn. So you can see that 1 raised to the power 3, it will become 1 raised to the power 7, and 3 raised to the power 7 into 3, that is 21. So 1 raised to the power 7 will give you 1, and you can just leave the answer because we just have to simplify this. Fourth part I have taken here, this law is there that a raised to the power m and b raised to the power n, m if we have, we can write this in the product and power as the whole power we can take. So similarly we will use the law here, that this is giving us 56 raised to the power 1 by 2, and you can leave the answer here itself. The remaining parts you will be doing yourself, and with this we have finished this chapter, but I have to give you some extra questions because the questions which are there in the textbook, they are so easy and we don't ask these kind of questions in exam. I will be giving you extra questions. Please practice the similar kind of questions from your extra book. And also those who don't have extra books, I am giving the questions here. Please practice them and ask if you have any doubt in those. So here are some extra questions of rationalizing the denominator, of simplifying the irrational numbers. So I hope you can easily do these questions. I am solving some of the questions which I gave, and so that you can get idea how to solve the questions. So first one, fourth part I have taken. See, this is a plus b whole square. So a plus b whole square, the identity is a square plus 2 into a into b plus b square. Fine, so you should write that identity over here using a plus b whole square identity. Now how to find the square of this one? You can see that 2 square will give you 4 and root 5 square will give you 2 square 4 and root 5 square will give you 5. So this is 20 plus 2 2s are 4, 4 3s are 12, and 12 root 5 into root 2 will give you root 10. Then 3 root 2 whole square, 3 square 9, and root 2 into root 2 will give you 2. So 9 2s are 18. Further we can add these numbers. This will give us 38 plus 12 root 10. I have taken fifth part of question number 2 where you have to rationalize the denominator. So if you remember how to rationalize the denominator, we should multiply the numerator and denominator by rationalizing factor. So in this case, what is rationalizing factor? It is root 3. Fine. So we are getting 3 and this will get multiplied with the whole root 2 plus root 5 and this will give us root 6 plus root 3 into root 5 will give us root 15. And those who don't know how to multiply the irrational numbers, they should see the previous video, they will come to know. Okay, now next part I have taken 9th part, where again you have to rationalize the denominator. So what will be the rationalizing factor? I am directly multiplying with the rationalizing factor here. Since 2 root 2 minus root 3 we have, so we'll multiply this by 2 root 2 plus root 3. That is its conjugate. And similarly the numerator also. So here we'll get a minus b, a plus b. So this gives us a square minus b square. That is 2 root 2 whole square minus root 3 square. And in the numerator this will get multiplied 3. First 3 will get multiplied with both the terms 2 root 2 plus root 3. And then 1 will get multiplied with both the terms 2 root 2 plus root 3. Now in the denominator a square, this will solve. 2 square will give you 4 into root 2 square, so 8 minus root 3 square, that is 3. Here this will multiply root 3 into root 2. So this will give you root 2 root 6 plus root 3 into root 3 will give you 3 plus 1 into 2 root 2, 2 root 2 plus 1 into root 3 will give you root 3. Now here all the terms are unlike terms, so we'll leave the upper part, that numerator, in this form only, and in the denominator we have rationalized and we are getting 5 as denominator. Now I have taken B part of third question. Here also you have to rationalize and simplify. So first rationalize. For rationalizing we will multiply by its conjugate, the numerator and denominator both. Fine. Now we are getting a plus b, a minus b in the denominator, so we will get a square minus b square. And in the numerator we will have to multiply both the terms. So we are getting 2 root 3, 7 minus 4 root 3. Now here what are we getting? 5 7s are 35 minus 20 root 3 plus 2 7s are 14 root 3. Minus 2 4s are 8 and root 3 into root 3 will give you 3. So 8 3s are 24. And if you have little problem, you can just calculate on the rough work also, rough column. 7 square will give you 49 minus, now 4 square 16 and root 3 square into 3. So 16 3s are 48. So the answer is 35 minus 24 we can solve. So we will get 11. And minus 20 plus 14 will give you minus 6 root 3 whole upon 1. So this is the answer. Question number 4, we have to simplify. So whenever you are getting the question of simplify, first you will see the denominators of the terms. Here we can see the denominators are conjugate of each other. So either you can rationalize the terms separately, or when the conjugate is there, directly you can take the LCM over here. So I am directly taking the LCM. If you are taking the LCM, you will see when the numbers are co-prime. How do we do? For example, if I am having 3 upon 2 plus 5 upon 7. So these are the co-prime numbers in the denominator. So we directly multiply them. And similarly here also we can directly multiply them. And since it is a plus b, a minus b, so we will get a square minus b square after multiplying these two terms. Now we know that how we should proceed. In this case, this will get multiplied with this term, that is root 5 plus root 3 whole square we are going to get, and root 5 minus root 3 will get as whole square. How I am getting this? Again we will move on to the same example, that 2 7s will give you 14. So 7 is getting multiplied with 3. And here 7 2s is giving me 14. So 5 2s. This is why we have multiplied this with each other. Now, you can solve this by identity again. This is a plus b whole square. So we'll get a square plus b square plus 2 into ab. That is 2 into 15. Plus here we'll get a square plus b square minus 2ab, that is minus 2 root 15. I am directly doing it here. You can first apply the identity and then you can solve. Okay, so this will give us 5 minus 3. So you can see here we are getting 8 plus 2 root 15 plus 8 minus 2 root 15 upon 2. So this will get cancelled and we are getting 16 upon 2. Answer is 8. So one important point to note here is that if you are getting the questions like this where the denominators are already conjugate of each other, you can directly take the LCM, or if they are not the conjugate, you will rationalize the terms separately and then you will solve in the similar way. As I have given you second and third part of the same question, you try to do them, you try to rationalize the denominator separately and then try to solve it. That's it for today, and the answers of remaining questions we'll discuss in the next video. So please do the questions, practice the questions and let me know if you have any doubt. We'll solve your doubts in the next video. Thank you.